Hello, I'm Jack Bowman, and today we're going to be talking about area approximations using left, right, midpoint, and trapezoidal methods. We will be using the graph y equals x squared. This is a very simple way of finding an area under any curve. However, there are many places where you can mess up during each step in these methods, but I'll explain those later on in lesson. The first method I will explain is the left method. Here we have the curve of the line graph with some x-coordinates below. Varying on each problem, there will be a certain number of subsections. In this problem, there is 4. So we can now draw these subsections in while making a rectangle to the left once the point hits the line. Here it goes like that, then this, then that, and then the last one there. We will keep repeating this process until we have 4 boxes. Now is the easy part. Since a rectangle's area is height times base, we can see that 1 times 1 is equal to 1. And for this box, 1 times 4 is equal to 4. And 1 times 9 is equal to 9. And 1 times 16 is equal to 16. Once you add each of those areas up of each of the 4 rectangles, you will then get an approximated area of the curved line. However, since some of the area is over the line, we will get an approximation that is greater than the actual area. Now let's move on to the right method. Again, we will have the same subintervals and the same x-coordinates. When we make rectangles to the right of the curve, we can see that there are only 3 rectangles. This is because when the height is 0, we will get 0 at this first point. Therefore, there will be no rectangle because the area will be 0. Here, it would be 1 times 1 for the area of that box, 1 times 4 for the area of this one, and 1 times 9 for the area of this one. Those added up will equal 14 units squared. Also, this approximation is less than the actual area under the curve because there is area that isn't being filled in under the curve. Once the areas are added, you will get your answer. Now we will move on to the midpoint method. Here you can see that we have 5 coordinates on the same line. However, we're only using just 2 x-coordinates for our midpoints. Now we could draw the dotted lines up from these midpoints to make a rectangle that connects to each of the points surrounding them. And then from there, we could calculate the area of the rectangle by multiplying the base, which is 2, times the height, which is 4. Making our area 8, plus the other triangle, which the base is 2, times 16, which will equal 32. When those areas are added together, we will get the answer of 40 units squared. Now this method is a lot more accurate than the left and right because you have some area above the curve but also some area under the curve, almost evening each other out. We can now finish up by using the trapezoidal method. This method seems a lot more complicated. However, it really isn't. Here, we will take the height of each side, add them together, multiply by the height, and divide that by 2. Because the area of a trapezoid is 1/2 times base 1 plus base 2 all times the height. So for the first one, we will have 0 plus 1 times the height, which is 1. And then all of that would have to be divided by 2. And here it would be 1 plus 4 times the height of 1, all divided by 2. and then 4 plus 9 times 1 divided by 2, and then 9 plus 16 times 1 divided by 2. Then you'll get the areas of each trapezoid, and those added up will equal to the total area under the curve. This method, just like the midpoint method, is also very accurate compared to the left and right methods. Now we can go over some common mistakes you may make while finding the area under the curves. For the first mistake often made, for the one where you're using the midpoints to the right, the first rectangle here would have 0 height, making it 0 as an area. But some people decide to add a rectangle, which is not what you're supposed to do. And also, another common mistake people make is during the trapezoidal area, where they multiply just the height times base 1 plus base 2 and forget to divide the entire thing by 2. That will make your answer a lot bigger than the actual area under the curve. Now that you understand the different methods used to find areas under the curve, you can go to my worksheet and work some problems out. Thank you.